Number one, sketch the graph for the function. So we have y equals 2 times 3 to the x power. I'm going to make a table of values to match up the graph with the correct, match up the equation with the correct graph. So start with -2. Um, if x is -2, 2 times 3 to the -2 power would be 2 over 9, which is approximately 0.222. Repeating. If x is -1, 2 times 3 to the -1 power would be 2 over 3, which is about 0.667. If x is 0, 2 times 3 to the 0 power is just simply 2. If x is 1, 2 times 3 to the first power would be 2 times 3, which is 6. And if x is 2, 2 times 3 to the second power would be 2 times 9, which is 18. So I know for sure when x is 0 goes, the y value is 2. So it cannot be A, it cannot be C, and it cannot be D, so it has to be this one here. Okay, so there's 0, 2, here's 1, 6, and 2, 18. The decimal ones are hard to see, but we were able to eliminate the other choices. Okay, number 2, again, we're going to do a table. When x is -2, it's 4 times 1 half to the -2 power, which is 4 times 4, which is 16. Okay. When x is -1, 4 times 1 half to the -1 power is 4 times 2, which is 8. When x is 0, 4 times 1 half to the 0 power is just 4. When x is 1, 4 times 1 half to the first power would be 2. And when x is 2, 4 times 1 half to the second power would be 1. So let's see. I like to use 0, 0, 4 as a reference. And this one doesn't work. This one doesn't work. And this one's close, but it doesn't work. The only one that works is letter C. You could see -1, 8, -2, 16, 1, 2, and then 2, 1. Now you're able to see all of them nicely. Okay. Simplify your answer. Your answer should contain only positive exponents. Okay, so remember regular numbers, you go ahead and multiply. So let me go ahead and zoom in for this. So you have 30, v to the -6, u to the 4th. And remember, if you have a negative exponent, you're going to take that value to the bottom, only that one. So it'll be 30 u to the 4th or v to the 6th. It's this choice here. Okay. 3x squared, y to the 3rd power, all of that to the 3rd power. Okay, so we're going to apply the power of a power rule. So we're going to distribute this 3 to all the exponents inside. This 3 still has an exponent, okay? It has an exponent of 1. So you have to multiply 1 times 3 for that one. So it'll be 3 to the 3rd power, x to the 6th power, and then y to the 9th power. And 3 to the third power is 3 times 3 times 3, which is 27. The answer is this one. All right. Simplify again. This is the quotient rule. When you have a fraction, when you're dividing numbers with the same base, you subtract the exponents. Okay? So 5 over 3, you cannot simplify, so I just copy it over. A to the 7th divided by a to the second power, so negative 7 minus 2 is negative 9. And then for B, 5 minus 3 is 2. Okay. And then the one with the negative exponent, the A, I'm going to move it to the bottom. So your answer is over here. All right, find the common difference. What's the pattern? 22 plus 2 is 24, plus 2 is 26, plus 2 is 28. So the common difference is 2. Find the next three terms after the last one given. All right, so negative 8, negative 108, negative 208, negative 308. What you're doing here is you're adding negative 100 each time. Negative 100. So the next one would be negative 408, negative 508, negative 608. So that's option B. Find the 52nd term. All right. First, let's see what the pattern is. From 25 to negative 35 to negative 45 to negative 55. The common difference is that you're subtracting 10. So negative 10 is your common difference. Okay. So now let's write the equation. A sub n is a sub 1 plus m minus 1 times d. So for the 52nd term, that's n. So A52 is equal to the first term, which is given. This is A1, negative 25, plus 52 minus 1 times the common difference of negative 10. Okay, so negative 25 plus 51 times negative 10 is negative 25 minus 510, which is negative 535 with this choice here. Find the explicit formula. So we're going to take this sequence and make a formula out of it. Okay, so here's the formula again. Okay, okay. And we just leave it as n. That's part of the formula. Here's the first term, a1. So it has to start with negative 23. And minus 1 is part of the formula. So now we just need the common difference. What's the pattern from negative 23, negative 26, negative 29? The common difference is negative 3. So your answer is here. Common ratio. With a common ratio, you divide the next term by the previous. So any two consecutive terms you divide. So 12 divided by 2 is 6. Okay, so BC. So any two would have worked. So if you would have said 72 divided by 12, that's also 6. Okay, but of course, easier to just divide 12 by 6. Okay, find the next three terms. Okay, so first we need to figure out how this thing is changing. How do you go from negative 2 to negative 8 and negative 8 to negative 32? Multiply by 4. And then I'm just going to check with the calculator. Negative 32 times 4 is negative 128. Good. So if I multiply that times 4, it's negative 512 times 4, negative 20, 48, and then times 4, negative 81, 92. That's going to be option C. All right, to find the eighth term, okay, first let's figure out what the pattern is. 3, 9, 27, 81. It looks like we're multiplying by 3. Okay, multiplying by 3, that's your common ratio. So for this one, the formula is a sub n is equal to a sub 1 times r to the n minus 1 power. Okay, so this is geometric. So this one's a little bit different. This one has its own formula. The ones above were arithmetic. Okay, so to find the eighth term, that means that n is 8. The first term is 3. The common ratio is also 3 to the power of 8 minus 1. So 3 times 3 to the power of 7. So remember, first you do exponents and then you multiply. So 3 to the 7th power is 2,187 times 3 is 6,561. All right, so for this one, we're going to write the formula. So first, let's see what kind of pattern this is. From 3 to 12, from 12 to 48. It's like you're multiplying by 4. So if you're multiplying, it's going to be geometric. Let's see, 48 times 4 is also 192. Good. So here's the formula that we need to write. N, just leave it as N. The first term is 3, it's given. And then the common ratio is 4 to the power of n minus 1. And that's going to be this option here. Okay. Find the 10th term in each sequence. Okay, so to find the 10th term, so let's figure out what the pattern is. 2.5 to 5 to 10 to 20. It's not adding 2.5, you're multiplying by 2. Multiplying by 2 each time, so r is equal to 2. So again, it's just going to be the geometric times. So if we want the 10th term, that's n. The first term is 2.5 times r, which is 2 to the power of 10 minus 1. Okay, exponents first, 2 to the power of 9. Okay, so I'm going to use my calculator. 2 to the power of 9 is 512 times 2.5 is 1,280. Okay, 15, find the 10th term. Okay, from negative 2 to 98. I'm not sure, but I could see that from 98 to 198, you add 100. And then you add another 100. Yeah, so it looks like the common difference is going to be 100. Yeah, negative 2 plus 100 is 98. Good. So to find the 10th term, here's the formula because this one is arithmetic. This is an adding sequence. So for the 10th term, it's the first term, which is negative 2 plus 10 minus 1 times 100. So negative 2 plus 9 times 100, negative 2 plus 900, which is 900 minus 2, which is 898.